All right, so here we're going to go ahead and talk about perfect square trinomials. Now this is a great shortcut if you remember how to do it. But perfect square trinomials, if you don't recognize them, if you factor them correctly, you'll see what happens. Basically, what a perfect square trinomial does is it comes in the form of a squared plus 2 times a times b plus b squared, which goes ahead and factors into a binomial squared, which means it basically is the binomial times itself. And we've seen that a couple times when we factor, right? But if you don't recognize a perfect square trinomial, that's fine. You can always just factor it as normal and it'll totally work out. And you'll see, oh, I got the same binomial. It was a perfect square trinomial. Recognizing it is nice. It's just a nice quick shortcut. But if you don't recognize it, you can still go ahead and factor it as normal and it'll still work itself out. So the characteristics of a perfect square trinomial, the first and the last terms are perfect squares. This has to happen or it's a no-go, okay? So notice that in my example here of a squared and b squared, they're perfect squares. The middle term is 2 times the product of the squares of the first and last term. This means it's 2 times the square root of a squared and the square root of b squared, the square roots. Like I said, if you don't remember the formulation or don't recognize it, you can factor it as normal. It's totally okay. We're only going to look at a few of these. So let's go ahead and start. The first one, I have x squared minus 6x plus 9. All right. X squared is a perfect squared. It is x squared. 9 is a perfect squared. It's 3 squared. And what you want to see is 6, 2 times the square root of the front, which is x, times the square root of the back, which is 3. So 2 times 3 is 6. It's 6x. This is a perfect square trinomial. Now remember, we also got to think about our signs. Our signs are going to be the same from my last. And our signs are both going to be minus. So this should factor out to be x, okay, minus 3 squared, or x minus 3. Okay, and let's go ahead and look at it and foiling it out. Okay, so I have x squared minus 3x minus 3x plus 9. So I have x squared minus 6x plus 9. It checks out. All right, and remember, you can always use your regular form of factoring to go ahead and figure this out. All right, so let's look at example 2. All right. The front is a perfect square here. It is y squared. 16 is a perfect square. It's 4 squared. And is the middle 2 times the front and the back, the square root? Yes, it is. Okay, so our signs are the same. They're both minus. So I have y minus 4 squared. Now I'll go ahead and invite you to go ahead and check that out and foil it and check it out. All right, 9x squared plus 12x plus 16. Remember, your first job is to go ahead and check whether the front and back are perfect squares. Okay, so the front is 3x squared. Remember, that means that's 3x times 3x, which is 9x. 16 is 4 squared, and is 12, 2 times 3x and 4, the bases. Okay, 3 times 4 is 12. All right, so is this a perfect square trinomial? Maybe I should have looked at something else. Let's go ahead and go back. Now remember, my first job is to do what? Look for a what? GCF. That middle was getting too big. So I need to look again and say, well, maybe I have a GCF here. 9, 12, and 16 all divisible by the same number? No, because 9 and 12 are divisible by 3, but 16's not. Okay, this one happens to be prime because the middle did not work out. So remember, if your middle's not 2 times whatever's going on here, if it's too big, this might not factor. Right, so in this case, example 3 is prime. This one does not factor, at least not as a perfect square trinomial, or as anything else for that matter. Example 4. All right, so we're looking here. Well, I already see 3 is not a perfect square. And I'm looking and I'm like, oh, here I have a GCF. And my GCF here is probably that 3. Let's go ahead and divide that 3 out. And left over I have x squared minus 10x plus 25. It's a little close here. And x squared is a perfect square. 5 is a perfect square. And is the middle 2 times those things? It is. So this one's going to go ahead. Looking at our signs, they must be the same in minus. Right? I have x minus 5 squared. And that 3 we pulled out at the beginning needs to come out front. Right? Remember, if you don't recognize perfect square trinomials, and they're not very common, remember you can always just factor it. And it will totally turn out. All right, so that concludes this. Go ahead and work on the remainder of the problems, and I will see you in the next video.